Welcome everyone to today's session, Evolving Perimeters with Guardrails and Not Gates. I'm Charlie Hamill. I'm a Principal Enterprise Architect with AWS, and joining me today are Chris Power and David Hocky, who are Cloud Solutions Architects with Comcast. We're going to hopefully give you something to take away that'll help you get your arms around what your teams are doing within AWS with regards to IAM security practices. We're going to talk to you about just a couple of things, because IAM is huge, that might give you things that you can layer into your existing accounts and get control over some things. We're going to start by me giving you a basic primer on some IAM things. We go really fast. But those things are important for you to understand what Comcast is doing along those lines. So David and Chris will come up next and talk to you about the journey they're on. So some of this may be very basic to you. You may know it already. You may be doing some of it, but it's good to know. So the first thing is, with IAM, you have the concept of principals. And principals are either users and groups, or they're roles. And roles are all kinds of things like assumed roles, delegated roles, federated roles, and service linked. Or there's applications. All of these things are principals. So an identity is a principal, and let's say that identity wants to do something in AWS, access some resource. So the journey for doing that is to make a request. And IAM gets involved at that point and authenticates that principal. Are you who you claim to be? And assuming the answer is yes, then the next step is to authorize what that principal can do. And authorization is all based on policies. The policies can be based on the identity of that principal, that person or service that's trying to do something, or they can be based on a number of other things like resources. So the resource itself can have policies in front of it that say what identities can or cannot do. And then there's a number of other policies around trust and permissions boundaries. So to give you an idea of how that works, we're going to take a look at two accounts. And we're going to look at a human being who wants to actually get onto the AWS Management Console. But someone has set up actually, no, this case is a human being wanting to get access to a DynamoDB table in another account that has a table in it about books. So the account on the right is the trusting account that they want to access. And the account on the left, on the right, is the person who wants to access that account. So we've got a trust relationship that has to happen. Now, in order for that to work, the trusting account needs to set up a couple of policies. So the first policy says that someone from a particular account, account A, can perform this action, which is assume role. So they're declaring here a policy that's going to let someone from the other account assume a role. And then the next policy is exactly what they can do once they assume that role. So in this case, the trusting account is explicitly saying persons who do that can do these basic read-only activities on DynamoDB, and it's very restricted to a particular table in DynamoDB that's about books. So with that, they've opened themselves up in a very explicit way to allowing account A to come into account B and do those things. Now, account A has to do something too. It has to make a declaration through a policy that its own users can go ahead and assume a role in that other account B. So with that, somebody in account A can attempt to access account B, and what they get is a temporary security token that has an expiration time on it. And that can be anywhere from 15 minutes to 12 hours. And they get it back, and now they can use that to access DynamoDB in the other account, restricted to only one table. Cross-account trust. Another way to assume a role is in identity federation with enterprises. So again, on the left, you have an enterprise. And let's say it's using Active Directory to authenticate and manage its corporate users. So typically, let's say there's a browser interface that a person inside the enterprise is using, and they're logging on. and they're logging onto their identity provider, which is Active Directory, and that will go ahead and look them up and return to them the things they can do in the form of a SAML assertion or a SAML token. And now, if you've gone ahead and prepared your AWS environment with trust to that identity provider, that person or that application can pass that SAML assertion over to AWS using a SAML endpoint, and AWS will validate it, go look them up, some things I'm not showing here, and return a temporary token that they can use to go ahead and do something. In this case, it's a human being attempting to use the AWS Management Console, but using their corporate credentials. They never had to log on to AWS to do this. And there they go. They're able to access the Management Console. And this can even be a fairly restricted access you give them. There's certain things on the console that they won't see, if that's what you want. So there's two examples of assuming a role. And the idea here is role-based security is one way to really get your arms around what people are doing in your organization. Now, the second thing we wanted to talk about under this initial primer that I'm giving you is something called permissions boundary. It's something that we introduced last year. And what it does is it limits the maximum permissions of the principals created by an admin. So you may have gone ahead and created permissions policies, and you've got principals acquiring those policies. And somebody else may come along, an admin, saying they're a little too permissive. I get why you want that policy, and in certain cases that's appropriate, but I want to get our arms around that and limit what folks normally do when they have that policy. So before, if you wanted to do that, it was pretty cumbersome. Somebody could, an admin could create a permissions policy, such as put user policy or attach role policy, that were very permissive, fairly unconstrained. And in order to allow that kind of thing in a self-service environment so that you weren't granting too many privileges, it is a non-trivial amount of work to automate that. Now with permissions boundaries, you can still have administrators creating these highly unrestricted policies and roles, but with permissions boundaries, it allows the developers to use those roles, but being confident there's some guardrails in place because the permission boundary is restricting it. Let's take a look at that in a little more detail. So here's an example of a delegate, an IAM administrator, creating a policy. And as you can see under the action, it's S3 star, CloudWatch star, EC2 star, it's everything. They can do a lot of things with this permission statement. But they've gone ahead and constrained it in a particular area, in the red there. And that constraint says, not so fast. On S3, yeah, you can do everything except, and you can't actually do anything on a particular bucket. The goal here is to really make sure nobody messes with this project bucket because it's got some stuff that we don't other people even seeing or touching. So that's what this does. So the next thing they can do is create a permissions policy that allows creation of IAM roles, but only if the company boundary policy that we just saw is part of that role. So this is now is a higher level admin saying, I'm going to let you guys go ahead and create roles, but when you do, you've got to put this company boundary policy in place, which is a permissions boundary. So the way the higher level admin will do that is say, go ahead, you can create roles, you can attach policies, you can delete policies, but the condition statement that you'll see there about midway through says it must contain the condition boundary policy, and so on. So the next step we have here is someone attempting to create a role specifying a permissions boundary. So they're doing the right thing here. This is another admin going along, creating a role, and it's called My Test App Role, and they're doing the right thing. They're saying the permissions boundary is the company boundary. So they've done the right thing here. And now they're going to create a permissions policy allowing full access to S3, the very thing that permissions boundary doesn't want you to do. But they can go ahead and do that because they really want the users of this role to do anything in S3 except what they're not supposed to do. It's the idea. And so there it is. Allow S3 anything. And now go ahead and create that new policy to the newly created role. And so the effect of that is that you've got this constraint created by the permission boundary, which says, you can't do anything on S3. This is one thing you can't do. But they made this statement, allow anything on S3. The two get together and create this result. When someone tries to browse to that restricted S3 bucket, they can't do it. So here's a Venn diagram that illustrates what we've just been talking about. And I'm going to test you. If you've been paying attention, you'll pass the test. We have a permissions boundary that says EC2 star, S3 star. We have a permissions policy, like we've just seen, that says EC2 star, SQS star. Somebody shout out, what is the resulting net permission this will give somebody? Correct. So there's the result of that. Now, all of that has been great, but it's still pretty fine-grained. It's down at the account level. It's down at the individual level. What if you want to get your arms through a bigger swath of accounts and what's going on? Well, this is something fairly new. Organizations has been around a while, and organizations, if you don't really get it yet, this is the idea of getting all of your accounts into a hierarchy and doing consistent things with them. So at the top, we have the master account. And so you can state things and restrictions and policies at the master account level that affect every other account underneath that. Or you can drive down further. You can organize your accounts under something called organizational units. And from there, you can have more accounts. It's a tree structure. And we see customers a lot of times doing things exactly like this. They want all their dev accounts having uniform policies, test and prod, and similarly. So you can do things with something called service control policies. It's fairly new as of March. And service control policies are a lot like permission boundaries, but they're at the organizational level. So you can do something at the master account level with a service control policy that will restrict or grant privileges that people didn't think about restricting or granting at a lower level. And likewise, at the dev organizational unit level, you can do it. So you don't actually have to attach it to an account. You can attach it to an organizational unit so that all the accounts under that OU have the same restrictions. And likewise, you could go down to the account level too. And there's some unique characteristics about SCPs. First of all, they do let you control which services and APIs are accessible. You can define the list of APIs that are allowed. You can define the list of APIs that you want to block. They can't be overridden by the local administrator of an account. Once they're in place, that's that. And the effective permission on an IAM role is the combination of the user and role and the intersection between the SCP and all the IAM permissions. So we've already seen the case of two circles combining. Now we've got three. We have the permissions policy that we were looking at before, and we had that overlaid with the permissions boundary, which resulted in EC2 star. And now we've got a service control policy coming along that says S3 star and EC2 star. Well, still the intersection is EC2 star, so that's the only thing a user that happens to have these three things in place can do. Finally, let's take a look at the journey IAM takes to evaluate policies. So the first thing IAM does, starting at the upper left, is to look for any deny evaluations. Are there any deny statements in any policy? If so, you can't do what you're trying to do. That deny always wins. Even if there's a conflicting allow, deny wins. The second step is, if there are no denies, look for allows. But look for them at the service control policy level. That's the big one. And if there's allow there, it's yes to do what you're trying to do, then let's keep going. Let's look at permissions boundaries. Are there any permission boundaries that allow you to do what you're trying to do? And if the answer is yes, let's keep going. Is there an assumed role that you're in? Are you assuming a role temporarily? And is that allowing you to do what you want to do? If it's yes, then we can keep going. Are your identity-based policies or your resource-based policies allowing you to do what you want to do? If it's yes, you're good. So with that, I want to turn it over to Chris and David, who will talk to you about the journey Comcast is on to actually implement a lot of this in their real world.
Thanks, Charlie. As Charlie pointed out, there's a lot of foundational building blocks that Amazon provides you as cloud and security architects to build upon, to govern securely and find that balance between productivity for your developers and governance and security. And we're going to talk a little bit today about how we have evolved our governance framework to meet both of those needs. As Charlie said, my name's Chris Power. I'm an architect on our cloud team at Comcast. The function of our team is largely to help drive strategy, best practices, implement governance, and we spend a lot of time sitting and talking with teams and listening to them. Both David and I come from application engineering backgrounds and product backgrounds. So we really want to find ways to strike the balance between governing and securing our cloud environments and operating those environments in a fiscally responsible way with the productivity that people approach the cloud to find. And so we'll talk a little bit about how we've done that. First, a little bit about Comcast. Most of you probably think of Comcast as a broadband provider, cable television provider. But we're much more than that. It's a media and entertainment company today. So we do broadband, we do cable, we do voice, Xfinity Mobile as a mobile service, and Digital Home, which is our home security product. But we also own NBC Universal, DreamWorks, Fandango, Sky as well recently through acquisition earlier this year. So really a global company that services a number of different industries. So from a scale and a context perspective, we're sort of setting the stage here for the landscape that we have to operate in when we're thinking about governing and architecting for the cloud. So when we think about scale and landscape, our team specifically is responsible for hundreds of accounts throughout our footprint, thousands of active developers on those accounts at any given time across a number of different regions. So we do use a multi-account strategy, which is something that I think a lot of folks have started to consider and are moving to. And we also provide access to dozens of different services within Amazon across multiple lines of business. In this case, we're talking about video and broadband and home and some of the things that we talked about. But when we think about governing the cloud, we like to strike a bit of a balance, and we have some guiding principles that help us understand how to go about implementing these tools. And we think of it in terms of guardrails, right, and not gates. And to be fair, we started in many places with gates, with tickets and things. We'll talk a little bit about that, but how we've evolved beyond that is thinking about developer experience first, right? But then balancing that with the need to have scale at our organization level, meaning hundreds of accounts and thousands of users, and the balance that we have with our partners in the security organization, our network teams, our software architecture teams, to balance all three of these things. We run a model that is, I guess, fairly decentralized from a development perspective. So we really try to encourage teams to choose the right services and tools that make sense for their use cases. And as a result, while we provide some amount of governance and guardrails, which we'll talk about, we don't necessarily restrict. You can't just be serverless, or you can only run EKS, or you can only run EC2. We're trying to kind of get to a place where we have some standardized models, but today teams are allowed to sort of pick what makes sense for them in the cloud and in our on-premise offerings. And so what does developer experience mean for us, right? We think of it in these sort of four axes, right? So agility, the ability to move quickly. Teams come to the cloud because they want to move quickly. They want to be able to get to market quickly. They want to be able to develop and turn around product features quickly and change direction. We want choice in architecture, choice in services, choices that work for your team. And we want a native experience, right? So all too often when you're building a governance framework in the cloud, you start building lots of custom tooling, and we did the same thing, that gets in the way sometimes of developers being productive. And so you need to find a way to strike that balance and provide as much of a native access into the tooling as you really possibly can. And the SDKs and other things. And obviously support for modern development practices, CI/CD, infrastructure as code, CloudFormation, Terraform, things like that. Ability for teams that want to use these things to be able to do so. So by way of example, this is a fairly common thing that we see developers doing, right? And I'm sure you all see this as well. I'm a developer. I'd like to build an API that's authenticated. There's some Lambda sitting behind it. Maybe it's talking to a DynamoDB table. We're capturing some metrics in CloudWatch. And we're tracing an X-ray, for example, right? So one of the first things you're going to find is that you need roles to accomplish this. In the ideal case, they're least privilege, and we think there's a strong argument to be made there for those. But teams need the ability to create roles to build this, right? And so when you're building a governance framework and you're trying to avoid things like privilege escalation or teams running and doing things with services or other resources that you don't want, oftentimes one of the things that you'll do is you'll sort of claw back the role create or user create piece. And we did the same thing. And so you end up with this sort of scenario, which we don't want, right? This is an anti-pattern if there ever was one, which is I'm a developer, I need to create a ticket so I can get a role, and then I create the ticket wrong and the role comes out wrong, and now I'm back creating that ticket again, and now I'm like a week into this, and all I wanted to do was create a Lambda function. Like, how can I get there much faster, right? And so we really wanted to avoid that and drive towards a solution that enables us to do those things and be self-service and be quick and agile, as we said. So what does our governance toolkit look like? Fairly typical pieces here, right? We've got IAM, organizations, as Charlie mentioned, service control policies, permissions boundaries are in there as well. And we'll talk about what this stuff actually looks like in practice. Like, how do we take those building blocks and employ those? CloudTrail, config, GuardDuty, we deploy those across all of our entire footprint. We've got custom tooling. We've got some third-party tooling as well. And of course, we've really started to lean heavily on single sign-on, multi-factor authentication for our users and the accounts. Today, we'll specifically talk a little bit about IAM organizations, some of the custom tooling we've built, and how we think about roles as principals versus users. So with that in mind, we're going to really cover two things here, right? Sort of the federated access experience that Charlie had talked about, role assumption, things like that. And then David will take a stab at the permissions boundaries themselves, how we've actually implemented this, how this is actually working, some of the things that we've seen work well, and some of the things that we are still working on, as this is an ever-evolving journey for us. So the federated access experience is often the things that developers see first, right? They get their account. What are the first thing they want to do? Use the CLI, log into the console. How do they do that? Historically, we, like many of you, probably had IAM users scattered across all of your accounts. We did the same thing. As a developer myself, I had trouble remembering passwords across several accounts that I had. So probably 12 or 18 months ago, we started a journey towards moving away from IAM users, moving into a federated model that uses roles backed by Active Directory with single sign-on and multi-factor authentication enforced across our entire footprint. And to be fair, that took us some time to get there, right? It took us months to move off of IAM users, to move to roles, to convince developers and engineers and other folks that you don't need to have a long-lived set of access keys sitting on your laptop to access and interact with Amazon. So some of the advantages to this model, right? Single sign-on for all of our federated users. So I, as an engineer, have a single set of credentials that I use. It's the same set of credentials that I might log into my account with across all of my accounts, right? That's a win for me personally right out of the box. I get an MFA, push notifications, boom, right into the console. We'll talk about how we do this with the CLI as well. Now, we now have temporary access keys instead of long-lived access keys, which is a common attack vector in public cloud, generally speaking, with maximum credential ages. We now can tie the user's lifecycle to our HR systems. So when someone enters the company, we can add them to accounts easily, and when they leave, we can take them out of the accounts easily. We have consistent credentials, as I said, and as I mentioned, we're able to then move largely completely off of IAM users entirely to roles, whether it's a person, a service, an EC2 instance, and we have sort of one remaining case where we still use IAM users. We'll talk a bit about that. Some of the challenges, though, with identity federation, right? You need a customized SAML claim. You have to be able to go from your federated identity provider to a SAML claim that Amazon understands, and we've had to do some work to map that. We created our own directory structure to support that. And you need custom tooling for things like the CLI. There's some open source out there that you can start with, which is what we did, and I'll show how that works. So you need to work on that a little bit. So for doing CLI access from your laptop or running Terraform or maybe some other things, some tooling there. Some systems don't support temporary credentials, right? So if you're running a Jenkins on-premise or You need some service that you're running on premise that needs to talk to Amazon services. You can't necessarily have MFA involved per se. So today, that's the one use case that we do support IAM users for, which is, we call them service users, right? But limited to that only. And you need a way to manage user accounts mapping into, users mapping into Amazon accounts, right? And so we built some custom tooling around that, both API and UI, to allow people that own accounts to manage who has access to what accounts and what roles. And that's been pretty successful for us. I probably stole the thunder on this slide. So customized SAML claims piece, you really have to have a good relationship with your directory services team. You may be the directory services team. If so, that's great. Otherwise, really build those relationships. That's worked really well for us there. As I said, custom tooling, we started with an open source project and built both a Python and a Golang version that supports interacting with the CLI using roles and temporary credentials, and integrates into our AWS backend and in our case, Azure MFA for MFA. I mentioned this already, temporary credentials, issuing IAM users for service accounts is really the only place we do that today. And that's still ticket driven today. Actually, only ticketed process we have left from a IAM perspective. And as I said, need ability to map, and we built a portal and an API that supports that. So what does that look like from the federated console perspective? You may have used this before, identity provider initiated. So you get single sign-on, you essentially go to a single URL, sign into that URL, and then that gives you access to all of your accounts and all of the roles that you have access to in those accounts. So as a developer, I just check the radio box button that I want, click sign in, and it drops me right into the console. And the experience is actually the same on the CLI. So now it's a single URL, it's a single sign on and MFA to access all of my accounts. So from a federated CLI perspective, we now simply have a tool that everyone has access to that they can use to affect the same behavior on the CLI. So you hit that username, password, push notification, type in your token ID, whatever the case is, and it gives you the same list of accounts, the same roles that you had access to from the console. You pick the one you want, and then it drops a temporary access key, secret key, and session token into your local AWS credentials cache, and away you go. You simply then need to just specify the profile, as we did here with the command line option, or you can set an environment variable, and there's a number of ways. And the nice thing about this is this works just fine with CloudFormation if you're running it from your local machine. If you're using Python code and you're running things in the SDK, or if you're building infrastructure with Terraform like many of our teams do as well, this worked quite well. And so you get this experience now with the federated access that you typically, historically, had to use IAM keys for, but without needing to do that. And we've seen a lot of benefit there because now we don't have keys floating around in different places. So with that, I think we'll turn it over to David, and he will talk a little bit about how we've actually then built out the management of roles that we talked about in our example.
Thanks, Chris. So I'm going to talk a little bit about our role management experience. So I think Charlie and Chris really set the stage for why do we need this? Why is it important that we have a mechanism for role management? And when we think about the product evolution of a service like this or a feature like this that we want to enable for developers, we think of it in kind of three phases for almost everything we do, right? It's first, there's probably a ticketed process. Users can't do that themselves. Then perhaps there's an out-of-band process, and then finally the best case scenario for us is a delegated native experience, and that was our approach to role creation as well, right? We got together and we thought, okay, do we want to do this roles as tickets thing? Do we want to do something called role vending, which I'll talk about momentarily? And how do we get to native role creation? How do we get comfortable as an organization that we can do this in a secure way? So pretty quickly we threw out this concept of roles as tickets. We were like, this is not going to happen. We're a very small organization, talking single-digit number of people supporting thousands of users. Roles as tickets was never going to fly. So we started with a concept called role vending, which I'll talk about now. And this is what a role vending machine looks like for Comcast. So you can imagine you have a client, they authenticate to an API gateway through some sort of custom authorizer in Lambda, which applies some sort of business logic that looks at your attributes and says, do you have access to the account you're trying to vend a role in? What kinds of roles can you create? Once it makes that enforcement decision, you have another Lambda function which calls the IAM service, creates a role, attaches some sort of permissions to it, and you're off to the races, right? So the advantages to this, of course, is that it's self-service. We can make it programmatic. We can provide an API. So everything we do is driven by this philosophy that anything that you can do in the kind of the console experience that we built has to also be available in an API. So none of this like, okay, you have one thing that the console can do and then your feature parity and the API lags because of that. We wanted to avoid that experience. So what does a vended role look like, and why did we do it? So we did this before permission boundaries existed. So we were fortunate enough that actually our implementation looks very similar to permission boundaries. So on the left, you can imagine that we have a developer role. It's a federated role. And you might give them something like power user access, which is an AWS managed policy. And that managed policy allows you to run the gamut of AWS services, which is important to us, but it doesn't really let you use those services because most of those services, outside of the lower level services like EC2 or S3, require roles to actually instantiate that service and then have it be able to communicate with other roles. So we added this additional policy, which in this case we're calling the role manager policy. And that role manager policy gives some limited permissions, in this case to attach and detach AWS managed policies, provided that they meet a few criteria. So one of the first criteria is that it matches some role naming convention which we came up with. Part of this is to support APIs which don't have support for condition keys. The other reason is it helps us really audit and identify these roles. It makes searching CloudTrail logs much easier, for example. And lastly, we say you can do this such that you can take these actions such that the resource that you're trying to attach to that role or detach to that role is something we call a protect policy. So what does the role look like once you've vended it? So you go to this portal or you instantiate this API, and you say, I want to create my test role. And that role we prepend with this custom role path. And the only thing in that role, besides the trust policy by default, is an attached protect policy. And most importantly, what that protect policy does is it says, you can't remove me, right? So the most important thing it does is it protects itself. And then subsequently, it applies those guardrails, those maximum set of permissions that really restrict kind of access to secure resources or services which might not be permissible to that user. And then, so because of this, now this user has been able to create a role which now they can apply any set of privileges that they want. And because, as Charlie mentioned, the evaluation logic, denies always win, these denies that are in this protect policy prevent the user from adding star permissions and having that actually be effectively star permissions. So what are some of the challenges, though, with role vending? You have to be really careful with your testing of this pipeline, right? You saw a lot of custom steps that we had to implement to get to ultimately the created role experience, right? It's not until like the fourth or fifth step that you actually hit an AWS API to do any of this, right? And you also have to validate the policies that you're vending. It was not trivial to create a policy which couldn't be removed by itself. Once we got it working, it was great, but it took a lot of kind of pre-work. And there's a lot of validation and error handling you have to do because of the eventual consistency of IAM. I don't know if any of you have ever tried to create a role and then attach a policy immediately after, like in a Terraform or something like that. Sometimes it fails, right, because that role hasn't propagated yet. And so when you're talking about needing to attach a policy, which is kind of like your guardrail, that can't fail, right? So we'll talk about how we address that. And then lastly, the roles have to be pre-created, right? So you have to have this out-of-band AWS an experience that's out of band of AWS. So you really have to educate your users, and they have to understand, like, oh, I got this dreaded, like, users not authorized to create IAM, create role. What do I do now? It's a super generic message. They search Google. Google tells them, become an administrator, sign in as the root account. We're like, no, that's not going to work for you. So how do we address these challenges, right? So of course, typical software development practices are really what we implemented at the core of this, right? We're treating it as a product, and that product needs to be, really hardened in code and validation, right? So we have integration tests, unit tests. We actually treat the creation of these protected roles as a single transaction. So if any tasks fail during the creation of these roles, we roll back every resource that was created so as not to risk leaving a role in a potentially bad state where it could be used for privilege escalation. You still have to have some sort of pre-created role process. There's nothing really getting around that in this world. So we published a lot of documentation with examples on how do I get started, how do I invoke the API, how do I use the UI. And then we also actually, to make it even a little more programmatic, inner-sourced a Terraform provider which actually would wrap our custom API that teams who are consuming Terraform could use to manage those resources without having to import them in a very non-Terraform supported way. And we thought about this and it works, but we were like, can we do better, right? We continued listening to application teams, focusing on that developer experience, wanting to increase agility and that native experience, and increase support for infrastructure as code. So how can we get there? And for us, that's really been permission boundaries. So permission boundaries has some advantages. It's a native experience for managing roles using the console, the CLI, the SDKs. And it's a lot less tooling that we have to manage, and to some extent removes out-of-band role creation. And the great thing is today it's supported by both CloudFormation and Terraform, which are pretty much our exclusive infrastructure as code tooling selections at Comcast. And so we can look at this architecture now, and you can see that it actually looks pretty similar to our role vending architecture. But the nice thing is that we've now swapped all of those custom components, that custom authorization, the resource-based access control, attribute-based access control, with the AWS native building blocks, right? So now, where before we had a custom authorizer and an API gateway, we have something like the AWS Management Console or the AWS APIs directly invoking IAM. So this allows us to get out of the way of our users, but still enforce some sort of permission boundary, which is the maximum set of things that we're comfortable with them doing. And so what does it mean to adopt permission boundaries? So one of the things we really loved about this was that the amount of changes that a developer who's coming, let's say, from outside the organization, or who's reading some documentation online about how do you create a role, how do you set the trust policy, how do you attach policies, is really minimal. So there's really just two things you change here. You have to adopt this naming convention we've implemented, again, just for reporting reasons and also to address those resources which only support kind of resource name-based restrictions. And the other is you apply permission boundaries. So you can see in this example of CloudFormation, I only had to change two things, and now my CloudFormation template, which previously would roll back, worked without a problem. So going from one to the other, far simpler than trying to educate users on going to this other portal which we created, which they don't recognize, it looks nothing like AWS, to now having this real native experience. Permission boundaries have some limitations, though. So you don't get away from testing those policies. Those policies still have to enforce kind of the maximum set of permissions that you're comfortable with. Today, you can only apply one, which is means you really have to be very thoughtful about the types of things that you'll restrict or allow in a permission boundary. The policy simulator doesn't support permission boundaries. So historically, we use the policy simulator to basically say, hey, let's validate that these resources or APIs that we want to call are protected. That doesn't work today, and hopefully that'll be there in the future. And lastly, while you can now create the roles in the console, when you want to kind of discover a service, you can only do that in the IAM console. The wizards, for example, like spinning up an EMR cluster or creating a Lambda, still require that you've pre-created the role out of band. But at least you can now do it in a native experience, something that'll work using AWS documentation, things of that nature. So how are we addressing these challenges, right? No getting away from just needing more testing, right? Being super thorough. one approach that we're taking, and I'll talk a little bit more about this momentarily, about how we're creating these boundaries, is that you have to ultimately end up providing multiple boundaries. And there's a few strategies for this, and I'll talk to you about the one that Comcast implemented. And then also you can move additional controls to AWS Organizations and SEPs. So historically, SEPs were super restrictive, and so you'd put everything on the IAM principle. With the features released earlier this year that Charlie was talking about, you can really now simplify your policies and then abstract that out into kind of broader controls. Nothing we can do here, again, about policy simulator support besides just adding more tests and really, in some cases, even manual testing to validate that these controls are being enforced properly. So I'm going to take a moment now to talk about this multiple permission boundary concept. Like, when you're thinking about it, you're like, well, okay, as an cloud administrator, do I basically have to create a boundary for every combination of services that someone wants to talk to, right? Like Lambda, they want to talk to RDS versus Lambda, they don't want to launch in a VPC and they wanted to talk to Dynamo. So we took a kind of different approach. Instead of looking at like a workload-centric approach, instead we took an approach which is based on a graduated maturity model. So the way we think about it is we created a user-centric approach to permission boundaries. So we took that concept of what AWS calls delegated administration and used that when we applied what permission boundaries can you create. So you can imagine in the simplest case, you have like these introductory users, they're new to AWS, you have service roles that like Lambda to DynamoDB communication, right? These are the least privileged roles. They're going to have they're going to be protected by a fairly tight permission boundary. Then you kind of have this next level of users who are more intermediate users. They're users or principals, like a CI/CD role, that actually need to be able to create roles themselves, right? So maybe they need to create things, these like level 1 roles. And then finally, we wanted to really enable our development teams and empower them. And so we created this third level for the most advanced users. So we really wanted to proliferate kind of the security knowledge of the organization, the security and AWS best practices into the organization. So for users which demonstrate a high level of maturity in terms of understanding AWS best practice, security best practice, as well as Comcast-specific policies through a certification process that we created, we will grant you permissions to be able to do more things and to be able to empower you to support your development teams as they increase their own maturity, right? And we've seen really good success of this. But again, this is all kind of at the microscopic level, right? It's like a principle within an account, but we have hundreds of accounts. And so there's certain things that we have to really scale across accounts. And these are security invariants. And we enforce those, using AWS Organizations and SEPs. So AWS Organizations really started as a cost view for us, a billing view, a usage view. And I think some people would say it's not relevant to this talk, but in a lot of ways it is, in that billing is probably one of the best ways to understand how people are consuming Amazon. There's very few things in Amazon that have no cost, IAM being one of them, but everything else you can really derive an understanding about what your users are doing based purely on kind of Cost Explorer, right? And that helped actually us define some of these controls that we would implement with SEPs. We also rely on some of the native service integrations. So things like CloudTrail have native integrations with organizations where you can deploy a trail in your master payer account, and it will actually deploy to all accounts within the organization and are not modifiable by any of the child accounts. This is a relatively new feature that people should definitely check out. And we also use it as our kind of account discovery framework. So like when we want to deploy changes or we want to audit something about accounts, we use this as the place to kind of enumerate all of our accounts. But there's still things we'd like to see, right? Like additional service integrations, things that are really push button that you can just enable. Support for account metadata is something we've been talking about for a long time. I think many organizations, such as ourselves, maintain a separate database of like your account and the cost center mapping, and perhaps like the email distribution list of that account, and really looking for a way to improve that. And then finally, an improved account lifecycle management. So today you can't fully automate the creation or closure of an account, which makes it really challenging to get away from that ticketed process again to something that's much more native. And in fact, one thing that we've been really happy about is that the organization service has been iterating very quickly, and support for account metadata actually launched about 2 weeks ago. So you can actually now tag accounts with interesting attributes, similar to being able to tag other resources in Amazon. So SCPs we use to kind of protect those resources and services within accounts, and it helps us to simplify IAM policies, as I mentioned before, which allowed us to really, it gives us a lot more room and flexibility to implement and iterate on those permission boundaries, because we can put some of those security invariants kind of at the organization level, the cross account, or even across all accounts. We can implement those with which gives us a much better sense of security when we go to make perhaps those permission boundaries even more permissive to, again, enable developer experience. There's some limitations, though. You're limited to 5 SCPs per entity, and they can only be about 5 kilobytes each. SCPs, though, can, of course, be applied at both the account, the OU, and organization level, but of course that doesn't scale nearly as much as other IAM principles like roles or policies. You have to be really deliberate about the design as a result. We're already finding that we're hitting that 5 KB limit with just some basic controls. And it creates a wide blast radius, whereas before, if we made a modification to an IAM principle, like a permission boundary or something like that, we could be pretty reasonably sure that it's only going to break like something within one account. If you misenable an SCP, you could affect multiple accounts. Or in the worst case, you could actually affect every account in your organization, including the one which you were using to manage the SCPs. So you could actually lock yourself out of Amazon and your entire organization. So be really careful with these. So I'm going to hand it over to Chris now to talk about what has this meant for us, right? And how our developers feel about this today.
Thanks. Yeah, so don't lock yourself out. So what does the experience actually look like today? Where have we evolved to? Today, account owners are happy, right? Because they can easily add users into accounts, assign them to roles, take away privileged access if they need to. Individuals are happy, developers, because they can use the console and the CLI to create the roles that they need to in a very simple, very native way, a way when you go out and start Googling, you'll find information on, right? Security's happy because we are federated, single sign-on, MFA. Teams are happy because they can manage those roles natively. And the technical leadership is happy because we've returned to teams the ability to be productive, agile, have that choice that we talked about with developer experience. So lastly, where are we going? Obviously, this is an evolving journey for us and continues to do so. We'd love to extend our use of SCPs to further simplify governance controls and simplify the permission boundaries. Expand self-service SSO roles. So when a person wants to access Amazon with one of these single sign-on roles, we'd like to be able to delegate the ability for teams to actually create and manage those things as well in a more fine-grained manner, and we're working on that. And launching self-service IAM users is another thing that's kind of on our roadmap, and as well as taking the concept of that graduated maturity model and really using that as a mechanism to drive maturity into the organization from a security, from a governance, from an IAM, and from a least privilege perspective. And with that, I think we've got just a few minutes for questions, so I'll stop there and say thanks and see if anyone has any questions.